Alright, so let's go and do two more examples here. How to use a rational roots theorem. I guess I don't need a mask. Let's take that off. But you should look at it. I don't know if you can see it, but it's a good slogan. So I'm going to put that right here. Yes. Hopefully that was in focus. Okay, here we go. So looking at this polynomial, what is the degree? Well, the degree is the highest exponent, which is again 3. So I know this is going to have 3 roots. Now what we're going to do is try to come up with a list of the possible rational roots. If you remember our rational roots theorem, it says let's take factors of -2, which are plus or minus 1 and 2, and divide it by, that's our constant term, let's divide it by factors of our leading coefficient, which is also 2, has factors of plus or minus 1 and 2. So what we're going to do when we come up with our list of possible rational roots, it's going to be plus or minus, I've got 1 and 2 over 1 and 2. So when we write this out, we have to look at all possibilities. So I usually try to do the smaller numbers first. Our smallest number here is 1 over 2, which is 1/2. Then if I do 1 over 1, that gives us 1. We do 2 over 1, that gives us 2. And then if we do 2 over 2, that's going to give us 1 again, and we already have it. So right here we have 6 numbers that could be roots. And again, we're going to have 3 that actually are roots. So how do we know what to plug in? Well, I usually just start with an easy one, like 1 or -1. But you can just choose one. So I'm going to choose 1. I'm going to test, does 1 give us a remainder of 0? So now we're using the remainder theorem. We're going to plug in 1. When I do, I get 2 times 1 cubed, which is just 2, plus 3 times 1 squared, which is just 1, so 3, and then minus 3 minus 2. You can see this is going to be 5 minus 5, which is 0. Hey, so again, we got lucky there. We were able to find a root on our first guess. If we didn't get it here, then we would just keep plugging in until we got 0. So now, what does that tell me? That tells me that 1 is a root. We have 3 roots and 1 worked. Nice. Now, it also tells me that x minus 1 is a factor of f of x. So what we're going to do is we're going to take f of x, and we're going to divide it by x minus 1. And we can use long division or we can use synthetic division. I'm a fan of synthetic division. It's just a little smoother and faster. Let's remember our root is going right here. It's what turns out to 0, so I put a 1. Then we're going to look at our polynomial, make sure it's in standard form, make sure nothing is missing. And then we're going to write our leading coefficient, or our coefficients here. We've got 2, 3, -3, -2. Now we know we're going to get 0 as the remainder, but we're more interested in the quotient now. Bring down the 2. 1 times 2 is 2. Add the ones above the line. 3 plus 2 is 5. 1 times 5 is 5. -3 plus 5 is 2. 1 times 2 is 2. -2 plus 2 is 0. Okay, that 0 represents our remainder. 2 is our constant term, our linear term, and our quadratic term. So let's write this out. I am left with 2x squared plus 5x plus 2. Now looking at this, does that factor? Well, it looks like we'll need to use split and group. If you don't want to use split and group, you could keep going in here. You could start plugging in other numbers till you get 0 and do synthetic division again. And that's a way you could just avoid factoring. But I'm going to show you the factoring by split and group because you need to know how to do that. When I have a leading coefficient greater than 1, which is what I have here, then what I'm going to do is my goal here is I'm going to split that -5, or that 5 here up into 2 terms. So instead of having a trinomial, I have 4 terms, so I can do grouping. So to start this out, I'm going to multiply the 2 times the 2, and that's going to give me 4. And I'm going to say what multiplies to 4 and adds to 5. Well, factors of 4 are 1 and 4 and 2 and 2. The only way we're getting 5 is if we do 4 and 1. So what I'm going to do is I'm going to split up that 5x as 4x plus x. And that's legal because 4x plus x is 5x. We didn't change any values, we just split it into another term. The other ones are going to stay the same here. But now since we have 4 terms, we're going to do grouping. In grouping, I split it into groups. And I say, what is the greatest common factor in each group? In this group, I can factor out a 2x, and that leaves behind x plus 2. For the second group, well, if they don't have anything in common, you can always factor out a 1. You know you're doing this right if you get the same thing, which we've got an x plus 2 here, and x plus 2 here. So pretend this whole thing is in one big parenthesis, and look, they both have in common, so factor out the x plus 2 to the front. When you're done, you're going to get x plus 2 out in front, and what's still left over is 2x plus 1. Now, what makes each of those become 0? It's more obvious to see from here, but x plus 2, that's negative 2. That was pretty obvious. But sometimes people struggle with 2x plus 1 because there's a 2. What makes that become 0? Well, I'm going to come over here and just do some simple algebra. Let's solve for x. I'm going to subtract 1. So 2x equals negative 1, and then I divide by 2. And that negative 1/2, that's going to be what makes that become 0. So now let's summarize this all. My roots for this polynomial, roots of f of x, are, we first found 1, and then we found negative 2, and negative 1/2. There we go. That's how you find the roots for this one. Let's go through one more example, and hopefully that will help solidify this for you. Alright, now looking at this one, how is this one going to be different from ones we've been doing? Let's start at the beginning. What is the degree? Well, the degree here is 4. That means we've got 4 roots. That means we're probably going to have to repeat this process more than once. Let's see how it works out. So I've got degree is equal to 4. So how do we come up with our possible rational roots? We're going to take factors of the constant term and divide it by factors of the leading coefficient. Numbers that multiply to give me 12, well, I've got 1 and 12. I've got 2 and 6. And then we've got 3 and 4. So there's a lot more factors of 12. And we're going to need to divide those all by factors of 2, which are 1 and 2. So let's see how many that's going to give us. So I'm going to look at our possible rational roots. So I've got plus or minus 1, 2, 3, 4, 6, and 12, all divided by 1 and 2. Alright, so when we're going to look at those, I think we're going to have quite a few numbers here, okay? Let's take all of those, and I usually try to go from low to high. We'll see if we get them all here. We're going to look at, our smallest would be 1 over 2. So I've got 1/2. So I'm going to 1/2, and then I'm going to do 1 over 1, or 2 over 2, I get 1. Then I'm going to go 3 over 2. When I do 4 over 2, I'm going to get 2. Or if I do 2 over 1. Then I'm going to go up to 6 over 2. That's going to give us 3. And then when I do 6 over 1, I'm going to get 6. 12 over 2 is also 6. And then lastly, if I do 12 over 1, I get 12. So let me do a quick check. We got 1/2, 2 halves, we got 3 halves, 4 halves, 6 halves, 12 halves, and then over 1. I think that should be all of them. Oh, I didn't put 4 in there. Thank you. I heard someone whisper through the camera, "You forgot 4." Okay, there it is. Okay, so if we look that, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 is 16 possible rational roots. We gotta find 4 of them. Now, there might be times where you gotta just plug it in and you get 0, and sometimes you do and sometimes you don't. So let's just hope we get lucky here. I'm gonna start by looking, do I like the looks of 1? Let's try it. That's all you can do. So I'm gonna plug in 1. F of 1. When I do, I'm gonna get 2 minus 3 minus 15 plus 32 minus 12. So let's combine the positives. That gives me 34. Let's combine the negatives. That's going to give me, oh, I think right here that's negative 27, negative 30. So I only got 4 there, so didn't work out. So 1 is not a root. Well, if 1 didn't work, maybe a negative 1 will work. Let's try negative 1. When I do that, I've got to be really careful here, but whenever I have a positive power, it's going to cancel out. So here, this will be a positive 2. This will be a negative 1 times negative 3 is a positive 3. It'll cancel out there, and that'll be a minus 32 minus 12. Oh yeah, this isn't going to work out. If you look right here, the negatives are much higher than this one. I'm not even going to add it up, because I know it's not 0. Okay, so it didn't work out there. Well, then let's just keep on rolling. We got to find one that works. So now, I really don't want to plug in a fraction. I'm going to go and try 2. Now the numbers are going to get pretty high here, but hopefully I can work with it. 2 to the 4th is 16. 16 times 2 is 32. 2 to the 3rd is 8. 8 times negative 3 is negative 24. Okay, 2 squared is 4. 4 times negative 15 is negative 60. 32 times 2 is 64. And then minus 12. Okay, let's combine our positives and negatives. So I've got 32 plus 64, that's 96. We combine our negatives, that would be negative 84 minus 12 is negative 96. Yes, that gives us 0. Yes. Okay, cool, we got it. So we got 2. 2 is a root. So I'm going to put a little note here. 2 is a root, which also means that x minus 2 is a factor of f of x. So what we're going to do next is we're going to take f of x and we're going to divide it by the quantity x minus 2 using synthetic division. When I do, I'm going to get 2 on the outside, like this, and then we're going to write out our coefficients 2, negative 3, negative 15, 32, and negative 12. When I do that, I'm checking to make sure they're in order, I'm not missing any exponents, and we're good. So let's just go through our steps. Bring down the 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. Negative 15 plus 2 is negative 13. 2 times negative 13 is negative 26. 32 minus 26 is 6. 2 times 6 is 12, and negative 12 plus 12 is 0. Now, what does this represent right here? This is my remainder, my constant, my linear, my quadratic, and my cubic coefficient. Now, I'm going to write that off to the side here, and I think you'll see why. So now that I factored out one of them, this is f of x over x minus 1. This is going to be 2x to the 3rd plus x squared minus 13x plus 6. Can we factor that? Like, nope, we can't factor that. I can try grouping, it doesn't work. So it means we're going to have to kind of just keep going here. Now, my list of possible rational roots, we're going to have a lot of similarities here, except 12's out, right? Because we did factors of 12 over 2, and now we're doing factors 6 over 2. Now, if 1 and negative 1 did not work before, they're not going to work now. So we're not going to test those anymore. But let's go and let's try using some of our other roots, okay? Maybe negative 2 will work. Maybe 3 or negative 3 will work. There's there's 4 roots and we only have 1, so we've got to find one that works. So now we're going to use this one, because it's shorter than that one, and let's just start plugging in values. So I'm going to use this one. Let's plug in -2. Now, it's not f of -2 because that's f of x. It's actually f of x divided by x minus 1. But I'm going to put a little note here. We're going to test -2. Now I got to be careful with the negatives again, but we got this. -2 cubed is -8, and -8 times 2 is -16. -2 squared is a +4. -2 times -13 is a +26 plus 6. And you know that's not going to work. This is going to be 36 minus 16. That's going to be like 20. So yeah, that didn't give me 0. So it wasn't -2. So then we're just going to keep on going. Is it going to be 3? Is it going to be -3? I'm actually going to try -3 to start this off. So let's test -3. -3 to the third. I'm going to need to get my calculator here. -3 times -3 is 9, and 9 times -3 is -27, and -27 times 2 is -54. Maybe I won't need a calculator. Let's just try it out. -54. -3 squared is a +9. -3 times a -13. That's going to be a +39. And then plus 6. Let's see. 39 plus 9 is 48. And 48 plus 6 is 54. -54 plus 54 is going to be 0. Alright, so what that tells me is it worked for -3. So -3 is a root, which means the quantity x plus 3 is going to be a factor. So I'm going to write x plus 3 is a factor. So now what we're going to do is we're going to divide by x plus 3. Now, I've already got this part right here. I'm just going to do another step of synthetic division, but now our number is going to be -3. So now I'm going to come down one, and we're going to do synthetic division again, but this time using -3. If we do it right, we should get 0 because we already tested it, and then whatever's remaining we should be able to factor and solve. So bring down the 2. -3 times 2 is -6. 1 plus -6 is -5. Times -5 is +15, -13 plus 15 is 2, -3 times 2 is -6, and that adds to 0. Awesome. When I'm looking at this is my remainder, my constant, my linear, and my quadratic term. So I've divided out once, I've divided out twice, and what I'm getting here is 2x squared minus 5x plus 2. Now, we are going to need to do split and group again. This looks very similar to the one we saw before, but it looks a little bit different enough. Let's just go through our steps. So I'm going to start off by multiplying the 2 times the 2 here. That's going to give me 4. What multiplies to 4 and adds to -5? And that's going to be -1 and -4. I think last time they were positive. So the order you put it in doesn't matter, but I'm going to write the -4x first. And let's scroll down and give us just, oh, no, actually, sorry, I can't scroll down or it's going to move everything. Wait, that might be okay. Might be a little messy here, but just, let's see if this works. No, that didn't do anything. Okay, sorry. Okay, so now what we're going to do is we've got the 2x squared and then the plus 2 here. Remember, we're going to do grouping here. So I'm going to look for the greatest common factor here and the greatest common factor there. So when I look at the greatest common factor of the first one, oh, sorry, I should have wrote that as -x, not +x. common factor of the first group is going to be a 2x. And when I factor out that 2x, I'm going to be left with x minus 2. I want to get the same thing over here, but you'll notice the signs are switched. So I'm going to factor out a negative 1, and that will switch the sign so I get x minus 2 again. I'm seeing x minus 2 for both of them. So now when I factor that out, I'm left with x minus 2 and 2x minus 1. All right, what that tells us is our two remaining roots, or whatever will make those parentheses be 0. X minus 2, what makes that 0 is 2. How does that work? Oh yeah, we already had 2, right? Well, is it okay to get a root more than once? Yeah, that's called multiplicity. That's fine. What makes 2x minus 1 be 0? We set it equal to 0 and solve, and you get 1/2. So if we summarize this, all of our roots, we started off by getting 2 to work. And 2 worked again later, so I have 2, but I'm going to say with a multiplicity of 2. So 2 was used twice. We also got negative 3 to work. And then after we factored, we got 1/2 to work. So that is how you factor, or that's how you find all the roots using the rational roots theorem, the remainder theorem, synthetic division, and factoring. Got a little crazy there, but hopefully that makes some sense. So try your assignment, and good luck.